Hi everyone. In this video we are going to discuss this example. So here we have this function and we have to find its Laurent's expansion for three different domains. So let us start with a given function. So what we have, let me write here. We have the function is, what is the function we have? 3 upon 2 plus z minus z square. So what we will do first, we will find the factors of denominator. So in Laurent series what we do, if you have any brackets, we make them separate and then we find Laurent series. So here we have one polynomial here. So first of all I will find its factors and I will form brackets there. Let us see what can we do here. See, first of all the highest power of z is 2 with negative sign it has. So I will take minus sign common, so it will have the positive sign. So I am taking minus sign common and I am writing in numerator. So it will be positive, this one will be negative and 2 will be negative. So let us find the factors. Minus 3. So we want two numbers whose product is minus 2 and the sum is minus 1. Product is minus 2, right, and the sum is minus 1. Then minus 2 plus 1. The product is minus 2 and their sum is minus 1. So that is correct. So in this way we found out the factors of that denominator, right? After that our target is to make them separate. We want something upon first bracket plus something upon second bracket. So for doing it I am going to use partial fraction. In partial fraction what we do, a upon first bracket we consider plus b upon second bracket we consider. Okay, so this thing we assume. So what are a and b? A and b are simply constants and we don't know, right now we don't know their values. We have to find the values of a and b. So to find the values of a and b we need to solve it further. We will cross multiply. So if you cross multiply a into this z plus 1 plus this b into z minus 2 and in denominator we take product of these two brackets z minus 2 z plus 1. Okay, so what is our target? Our target is to find the values of a and b. So let us write it here. Okay, see, actually these two terms are equal. We have written equality sign. So and having the same denominator, you can easily see. What will I do? We will cancel out denominators and simply we will compare numerators. So therefore I can write minus 3 is equal to, here the numerator is minus 3 and here numerator is a z plus 1 plus b z minus 2. So now what will I do? I will put value of z is equal to 0, 1, 2 like that to find the values of a and b. But we need to take care of one thing, that is we should get 0. If you get 0, easily we'll get the values of a and b. So see, for that purpose I am going to put z is equal to minus 1. See what will happen if I put z is equal to minus 1 plus 1, 0 and this term will be 0. So easily we will get the value of b. Getting? So let us see. So I am putting z is equal to minus 1, left hand side is constant, 3a minus 1 plus 1, 0, b. I am putting minus 1 here, minus 1 minus 2. So minus 3 is equal to, this is 0 obviously, minus 3b. Let us cancel minus 3 from both sides. So the value of b is 1. Okay, let us go further. So now I am going to put another value of z. So let us see, putting z is equal to, so this time my target is to bring 0 here. Last time for this one we had got 0 here, no? So this time we need to bring 0 here. So for that I am going to put z is equal to 2. So this 2 minus 2, 0. Let us see what we'll get. Minus 3 in left hand side a. 2 plus 1 b, 2 minus 2, 0. So minus 3 is equal to, this is 3a, right? 0 into anything 0. 3 will get cancelled and the value of a is minus 1. So therefore f of z. What is my f of z? F of z a. Value of a is minus 1. So I should write here minus 1 upon z minus 2. And value of b is 1. So 1 upon z plus 1. So in this way we have made them separate. So now it's very easy to find Laurent series expansion. So f of z is equal to this one. So you can see here we have three different domains. For three different domains, obviously we will have three different Laurent series. Let us start to discuss those domains one by one. Make a screenshot of it, then we will go further. So I have written the function there, okay. So let us consider those domains one by one. So the first case is for mod z less than 1. So let us talk about its geometry first, okay. What we have mod z less than 1. To find a curve, we replace this inequality by equality. So this is equation of circle with center 0, 0 and radius 1. So let me show here. Imaginary axis, this is real axis. So we have a circle here with center 0, 0, radius 1, 1, 0, right? So I have shown it by dotted lines since we have inequality there, getting strictly inequality. And it is less than 1, that means less than radius is less than 1, that means we get the interior part of this circle, okay, we get this open disk. So for that disk, we have to find a Laurent's expansion, okay. So let me remove this one. So before starting the discussion of this case, I need to tell you, or I need to remind you one important thing. For Laurent series, mostly we use two series, okay. So let me write here. The first series is 1 upon 1 minus z, which is 1 plus z square plus z cube and so on, with condition mod z less than 1, and the second is 1 upon 1 plus z. It is having just alternate minus plus signs, okay, mod z less than 1. So these are our favorite series, okay, these are our favorite expansion. So we are going to use in 99.99% problems of Laurent series, we simply use these two series, okay. We need to take care of those conditions. So those series are valid with that condition only, that is mod z less than 1, okay. So let us talk about this case now. What we have, let me write, we have mod z less than 1, okay. But see, as you can see here, we have two brackets, or sorry, two terms we have. So for two terms, we need to have two conditions obviously to expand as a Laurent series, okay. So let us discuss now. See here, when we will have denominator 0, if z is equal to minus 1, then denominator will be 0. That means that point minus 1 creates problem for us. As well as if z is equal to 2, then also our denominator is 0. That means that point 2 creates problem for us, getting? So that's why mostly we discuss cases mod z is equal to 1 and z is equal to 2. So mod z less than 1, so obviously it is less than 2, okay, it is less than 1, obviously it is less than 2. So as I told you earlier, so that minus 1 and 2, these 2 points create problems. So actually there is no any circle, but I am drawing one circle here, okay, with radius 2. So if any point lies inside this circle, this condition, no, if this point lies inside a circle, then obviously it lies inside this circle with center 0, 0 radius 1, and it lies with a circle with center 0, 0 radius 2. If mod z less than 1, obviously less than 1 as well as less than 2. That means it will satisfy both conditions. This thing I want to say, okay. So it is less than 1, obviously less than 2. But as you can see here, for that condition, we need to have 1 in right hand side. Here we have 1 in right hand side, but here we do not have 1 in right hand side. So for that, I am going to shift 2 on this side. So mod z less than 1 and mod z by 2 less than 1 by shifting 2 on this side. So let us consider the function f of z minus 1 upon z minus 2 plus 1 upon z plus 1, okay. So now there is one trick. That trick is whatever in denominator we take common. Nothing we have in denominator here, but see here we have 2 in denominator, that means we have to take 2 common. So from where, from which term we have to take 2 common? There is no any 2, so obviously I need to take 2 common from this side. Let us do that. Minus 1 upon, I am taking 2 common. So here we will have z by 2 and 2 will go outside. So only 1 is there. 1 upon z plus 1. Okay. Let us go further. So this is equal to minus 1. See, can we expand in that way? No. Because as you can see here, we always have 1 first. Here we don't have 1. So for that, we want this 1 here. So for that, I am going to take minus sign common. If you take minus sign common, that this minus and that minus will get cancelled to each other. Okay, so let me cancel it. 2 and I am writing 1 first since we have taken minus sign common, and this will be minus z by 2. Let me write properly. Plus 1 upon. So here also I need to do the same. We want 1 first. But see, plus is there, so we can easily interchange 1 upon 1 plus z. So my question is, see 1 by 2 I have written as it is. My question is, can we use this expansion 1 upon 1 minus z, 1 upon 1 minus z by 2. At a place of z, we have z by 2, right? But see, it should satisfy this condition. So z by 2 we have, so mod of z by 2 should be less than 1, then only we can expand in the same way. We have it, mod of z by 2 less than 1. We have already adjusted it. So let us expand. Same series I am going to use, just at a place of z we have z by 2. So 1 plus z by 2 plus z by 2 square plus z by 2 cube and so on. So this is the series we got. Plus. So yes, we have this series expansion, but let us see that condition is satisfied or not. Yes, that condition is satisfied here. So we can easily expand it in the same way. So same expansion, 1 minus z plus z square minus z cube plus and so on. So in this way we got Laurent series expansion for the given function for this domain only, unit disk, center 0, 0, radius 1. Let us go for the next domain, just make a screenshot of it, okay. So let us discuss case number 2, okay. So what is our case number 2? Second case is 1 less than mod z less than 2. So let us talk about its geometry. So to find a curve, we need to replace inequality by equality. So here 1 is equal to mod z, that means mod z is equal to 1. So this is equation of circle having center 0, 0 and radius 1. So let me show here, this is a circle we have with center 0, 0 and radius 1, okay. Since the standard equation of circle is mod z minus z naught is equal to r, so this is the center and this is the radius, okay. So I am comparing the given equation with that one and finding the center and radius. If you consider this inequality and if you replace inequality by equality, so we have equation like this. That means basically z minus 0 is equal to 2. So the center is 0 and what is its radius? 2. So let me show here, center 0, 0 and radius 2. So we have this circle with radius 2. So basically what have they mentioned? Mod z greater than 1. Greater than 1, that means exterior part, okay, it is the exterior of a smaller circle, and less than 2, that means interior of a larger circle. That means the actual region is bounded by these two concentric circles, right? So yes, we get region like this, okay. So this is the region we have, okay. So for that annular domain, okay, annular region, we have to find the Laurent's expansion, okay. So let us do that. Let me remove this part which is not required. So basically they have given two inequalities here. Let me write two inequalities. So we have, let me make them separate. So we have one less than mod z and the second is mod z less than 2. See, our target or our aim is to use those series, okay, for expansion of this function as a Laurent series. So we need to bring those conditions here so we can easily use this series. For those conditions, always we have 1 in the right hand side. Let us see that 1 is maintained or not. Here in the right hand side we don't have 1. So I need to shift this mod z on this side. So we have the condition like this. Here also I will do the same. I am going to shift 2 in left hand side. So z by 2 less than 1. So in the right hand side we have 1, so we are now very happy since the condition is satisfied, or the similar condition we have got there. Getting? Then consider the function. What is f of z we have? Minus 1 upon z minus 2 plus 1 upon z plus 2. I have already told you the technique. Whatever in denominator, we take it common. In denominator we have z, that means from one of them we have to take z common, and here denominator is 2, that means we have to take 2 also common. So now the question is from which term we have to take z common and from which term we have to take 2 common. You can easily see 2 appears only in first term, so that's why I will take 2 common from the first term, and obviously the remaining term is second term, so we have to take z common from the second term. So let us do minus 1 upon, I am taking 2 common here, there is no any 2, so that's why I should write z by 2. If I take 2 common, only 1 is left there, plus I have to take z common here, so it will come outside and only 1 is left there, and there is no any z, so I should write 1 by z. Since if you solve it, you should get the previous term again, right? So let us go further. So let me write in a simple way, minus 1 by 2, and this 1 upon z by 2 minus 1 and plus 1 by z into 1 upon 1 plus 1 by z. So as you can see in this series, let me show you. For those series or for those terms, we always have 1 first. Let us see that 1 is maintained or not. Here we don't have 1 first. So I need to take minus sign common. Getting? Since there is minus sign there. No, so I need to take minus sign common. So it will be plus and 1 will come first. And yeah, let me show here. But see, if I take minus sign common, already one minus sign is waiting for it. Minus minus plus. And we will have 1 by 2 into 1 by, see we have taken minus sign common, so that's why now sign will get changed, 1 will be positive and that z by 2 will be negative. Okay, so let me write 1 plus 1 by z into, here fortunately we have 1 first, so let me write as it is, 1 upon 1 plus what we have, 1 by z. So this is equal to 1 by 2, okay, agree, 1 by 2. So now the question is, can we use this expansion to expand this bracket? Same format we have, 1 upon 1 minus something, 1 upon 1 minus z. But see, at a place of z we have z by 2. So it should satisfy the condition. We have z by 2, so mod of z by 2 should be less than 1. Do we have this thing? Yes, mod of z by 2 is less than 1. So condition is already satisfied and we can expand it definitely. Let us use the expansion, okay, this expansion to expand this bracket. 1 plus z by 2 plus z by 2 square plus z by 2 cube and so on plus 1 by z. So can we use this series to expand it, since plus sign is there, no? 1 upon 1 plus z, 1 upon 1 plus 1 by z. At a place of z, we have 1 by z, right? So this condition we have for this series. So we have 1 by z, so mod of 1 by z should be less than 1, then only we can use that expansion. Mod of 1 by z is already less than 1, so definitely we can expand in the same way. Just at a place of z we have 1 by z. 1 minus 1 by z plus 1 by z square minus 1 by z cube and so on. If you want, you can multiply each term by this 1 by z. But see, it doesn't matter, this thing also required Laurent's expansion, you can say. So the second case is also over, we need to go for the last case. Just make a screenshot of it, then we will go further. So let us discuss the last case, right? So 2 less than mod z we have this time. Let us talk about its geometry. So for that, I need to replace this inequality by equality. So we'll have mod z is equal to 2. So see, this is equation of circle. Since I'm comparing with this standard equation, mod z minus z naught is equal to r. So this is the center and this is radius, right? Okay, so this is mod z minus 0 is equal to 2, so the center is 0 and radius is 2. So we have a circle with center 0 0 and radius 2. So this type of circle we have, but see what have they mentioned, it is greater than 2, that means exterior part of this circle. So the region is outside this circle. So yes, we have this type of region, right, outside this circle. Okay, I have shown in this diagram. So for that region, we have to find the Lorentz expansion. So let us go further. See what we have here. Let me write. We have 2 less than mod z. But as you can see here, we have two terms. So we need to have two conditions to expand as a Lorentz series. So how to bring the second condition? See, if anything mod z is greater than 2, obviously it is greater than 1. So let me write. So 1 less than mod z and it is greater than 2 also. 1 less than mod z. Getting? So it is greater than 2, no? So obviously it is greater than 1 also. Geometrically we can say it is greater than 2. That means it is in exterior part of this circle. If there is any point which lies in the exterior part of a circle with center 0, 0, radius 2. So if you consider any circle with radius 1, okay, so actually the mod z is equal to 1 denotes this smaller circle. So if any point lies exterior of this outer circle, obviously it is in exterior of a smaller circle also. So this is a geometrical meaning of it. So in this way we got two conditions. But see, finally we have to use those expansion for a Lorentz series. So the condition is mod z less than 1. That means in right hand side always we need to have 1. Here we have mod z in right hand side. So let us shift it in left hand side. So it will be in denominator less than 1. Here also I will do the same. I will shift to the left hand side. So it will be in denominator less than 1. So in this way we got two conditions where in right hand side we have 1. So let us consider function. What is the function we have then? So the function is minus 1 upon z minus 2 plus 1 upon z plus 1. So one trick we have, that is whatever in denominator we take it common. See, here we have z in denominator, so I should take z common. Here also we have z in denominator, so that means from both terms we have to take z common. Let us do that. I am taking z outside, so 1 is there. There is no any z, so I should write that z in denominator. Here also I will take z common, so 1 is left there, plus z is not there, so I should write 1 by z. Since when you solve the brackets, z will get cancelled and you will have the previous term, okay. So let us go further. So this is equal to minus 1 by z. So that minus 1 by z I am writing separately into. So now we have to find the expansion of this bracket, but see, my question is, can we use this expansion to expand it? 1 minus 1 minus, at a place of z we have 2 by z, right? So mod of z must be less than 1. That means that 2 by z should satisfy that condition. Its mod should be less than 1, then only we can use expansion. Mod 2 by z is already less than 1. That condition already we have. So we can use it, that expansion. At a place of z we have 2 by z. So let us do that. 1 plus 2 by z plus 2 by z square plus 2 by z cube and so on. This is the Lorentz series we have. Let us talk about the second term. 1 by z is there, so I am writing it separately. So can I use this expansion? Getting? So at a place of z what we have? 1 by z. So by that condition, mod of 1 by z should be less than 1, then only we can use it. So mod of 1 by z already we have less than 1. So let us expand. So I am using that expansion. Just at the place of z we have 1 by z. So 1 minus 1 by z plus 1 by z square minus, alternating minus plus signs, 1 by z cube and so on. So this is required Lorentz series for third domain. Getting? If you want, you can multiply each term by 1 by z. Here also you can do the same, but if you keep as it is, then also you can declare it is a required Lorentz expansion. So make a screenshot of it, then we will stop. Thank you. See you.